Hi folks, we're looking at the higher problem solving question from the 2016 paper. This is question 11, the experimental design question. Okay, so we're looking at colchicine, chemical used in plant breeding to induce mutations and produce cultivars. We are told it's sesame that is important and that they're working with sesame to determine the effects of colchicine concentration. You've got sesame seeds soaked in different concentrations for 24 hours, and then each concentration was taken, seeds were germinated, 50 of them were germinated from each concentration, and then 90 days later record total leaf area, the number of seeds and the mass of seeds per plant. So here's our data. So we've got 4 different concentrations of colchicine. You could argue there's only 3 because you've got a 0, so that's obviously just water. We've got our total leaf area per plant, which looks to be increasing as our increase our colchicine, and our number of seeds. Not totally perfect kind of system going 5-4, but we're kind of looks like it's pretty much dropping at the higher concentration, and the mass of seeds is increasing as we go up. Okay. Identify the independent variable in this investigation. So independent variable is the thing that you changed, and in this case, we were looking at the effects of colchicine concentration. If you just say colchicine, you're not going to get the mark. It has to be the concentration. State an aspect of the investigation which helped to ensure reliable results were obtained. Okay, here's our investigation again. How do we make things reliable? We repeat them, and here we have 50 plants were grown from each concentration. That's it. An important characteristic of food crops is the 1000 seed mass, which is the total mass of a sample of 1000 seeds. Calculate the 1000 seed mass for the plants grown from seeds in the colchicine concentration of 0.5 millimolar per litre. Okay, so we've got, I've still got that on highlighter, right? Okay, so we're looking at our 0.5, and we have 550 seeds per plant. And the mass of that 550 is 4.4 grams. We don't want 550, we want 1000. So you can either do this just by proportion. So that divided by that times by that. So 1000 divided by 550, and then multiplied by 4.4 gives you 8. Or if you prefer, you could have done 550 divided by 4.4, divide that by 550 to get your mass of 1 seed, and then multiply the whole thing by 1000 to take you back up to 1000, and that'll give you 8 as well. Express as the simplest whole number ratio the average total leaf area per plant from seeds soaked in a colchicine concentration of 0 to that at 1. So we have 0, we're going the average leaf area. So at 0 we have 1500, and at 1 we have 3500. So let's try some divisions here. Certainly I'm going to divide by 500, so we'll do that first. So that's a 3, and that's 7. Well, actually that's not going to go any further. So 3, 7. Explain the relationship between the total leaf area and the total mass of seeds. Okay, now this is worth 2 marks, so you're going to have to do some proper explaining. Okay, this is not describing, it's explaining. So what we have here, if we look here, we've got at 1500 we have 2.8 mass of seeds. When our leaf area goes up to 2315, you have 3.5. 2786 giving you 4.4. 3500 giving you 4.7. So as you increase the leaf area, you're increasing the mass of seeds. Explain the relationship. Okay, leaf area is to do with photosynthesis. The more photosynthesis you have, the more food is being synthesized, and the excess can be used as stored in seeds. That's where you need to link it all together. So it's about photosynthesis, and therefore more energy that can then be used to make the seeds. Here's your mark scheme. It's pretty straightforward. I think a reasonably straightforward one. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 marks. Okay.